Welcome to the episode club tonight. We are going to be talking about Voyagers, the Omega Directive, and Enterprise Cold Front. So we have some fun episodes to talk about today. I'm really excited. First up, we are going to discuss Voyagers, the Omega Directive. This is one of my favorite episodes of all time. I love it. It's I think one of the best Voyager episodes that people usually forget. Even I forget to mention it from time to time. But I love just the premise of it. I love the idea behind it. And particularly what I enjoy is this concept of an omega particle, like a perfect particle that can store so much energy that it can power a civilization in theory. Apologies. We were a little late up and going, so okay with that. But anyway, so in the Omega Directive, this is the one where they are doing their thing in the Delta Quadrant, and then suddenly everything freezes, and they're essentially just like, oh, hey, everyone. Everything freezes, and they get a big Omega symbol on the screen, and everyone's like, I don't know what this is. They've dropped out of warp. They have their sensors locked out. Hey, Andrew, you made it. And this big Omega symbol shows up, and everyone's like, TF? I don't understand what's going on. And, Janeway comes in, and she's like, shut it down. I gotta go deal with this. I know what's going on. Nobody talk to me. So they discovered this Omega phenomenon. Super secret Omega moments. Hey, Brad. So it turns out there's this Omega phenomenon that they discovered 1.2 light years away from where they are, and it's a need-to-know thing that Janeway, that's only, I think they said, captain level and certain Federation, like, employees, basically, from there up, are able to know about this Omega Directive. And the problem is that they're stuck in the Delta Quadrant, right? We still don't know exactly what this is yet. But Janeway is like, the Omega Directive, if we were back home, I'd be calling people, hey, Synth Pop. So she's trying to figure out what's going on. What we do find out, she starts techno-babbling, telling people what everyone needs to go do. They have to install multiphasic shielding around the warp core. Oh, thank you. And they're all kind of like, what? Why? We've never needed this before. So multiphasic, right? Multiphasic means multiple phases. So you're trying to cover up a bunch of spectrums. You have some shielding. And B'Elanna's like, that's cute. No. She's like, I'm going to need it in the next, 2 hours. And B'Elanna's like, science says no. Oh, thanks, Josh. And the only thing they could think of, everyone gets in, peak gossip mode, which I love. They're like, I think this is going to protect us from subspace radiation, but we've never needed to, protect the warp core from stuff like that before. So this is new. And then she also tells them to put thermal protection on the shuttlecraft that will protect them up to, I think, 12,000 Kelvin? Yay! That's awesome, Joel. They knew. That's really funny. I had no control over that, but they know us. I guess is what we'll say. That's awesome. So essentially, 7 of 9 comes in. I love it. 7 of 9 comes in, and she knows what's going on. She's like, Captain, I know what the Omega Directive is, because they have assimilated Starfleet captains in the past, and as such have assimilated all of their knowledge. Yeah, exactly. B'Elanna's like, I don't know how to do that. Because she hadn't mastered Scotty's art of expectation management, as he tried to teach Geordi. But yeah, good times. Do you think my name is Scotty? There is no way that we can do that. Cheers, DTG. This is caffeine. not as strong as I would hope for it to be. But yeah, and so 7 is basically like, look, Borg love this stuff. Right. Sorry, Picard. We can blame Picard that Lucutius is the one who gave up the Omega Directive to the Borg, which is kind of funny. I kind of love that. But she knows what's going on, and she's basically like, the Borg have been trying to harness this thing. So then they start digging into like what the Omega molecule actually is. And it's this like quasi-theoretical, yeah, I mean, we assume that there was more than just Lucutius, but at the very least we know that there was one. They essentially are like, there's this synthetic particle. Oh, hey, Val, nice to see you. That can contain a stupid amount of energy. I think it's probably the best way to say it. And it's synthetic, it's theoretical. The Borg have been trying to find it. Humanity's been trying to find it. All these other species have this idea of this Omega molecule, that there exists this molecule out there that can store a crazy amount of energy. Thank you. And the Borg have always wanted to harness it. They see it like almost as a spiritual thing, that there's this like God particle, this perfect particle, because with it, the Borg could exist forever, right? But then they talk about synthesizing it versus naturally occurring. Now, this is interesting. What this reminded me of is actually how we've discovered, yeah, the goddamn particle. We have synthesized hydrocarbon chains in the past here on Earth that we figured were always just synthetic, right? That we have, we've strung a bunch of hydrocarbons together, made these molecules for whatever need. And actually, since then, we have found hydrocarbon chains that we thought were only synthetic, that we hadn't found naturally occurring, particularly in Titan's atmosphere around Saturn. So this idea that you can have a synthetic molecule that also happens to exist naturally is possible, and is something that humanity, that we have found, and I assume we will continue to find. So that's kind of a good way to think about the Omega molecule here, is that they know that they theorize that this exists. They've tested it out and they've tried to make it in the past. And, but they also think that it could be naturally occurring as well. 7 says that when they tried to synthesize it, it lasted for 1/trillionth of a nanosecond, which is 1 × 10⁻21. That's incredibly short period of time, depending on how you interpret trillionth. I went with the 10⁻12. So that's probably a level of scientific notation detail that people don't care about, but you get the idea. That's not an infeasible time. So Planck time, yeah, so thank you guys. Planck time, so a Planck distance is the shortest possible distance, and then the fastest thing that we know can travel is the speed of light. And so you can interpret Planck time as being the amount of time it takes the fastest thing to travel 1 Planck distance, and that's 10⁻44 seconds. So we're still a long way off from actually Planck time. So times 10⁻21 is possible. Now, the connection to zero-point energy, that zero-point energy is one of these things that we use a lot in sci-fi, and the scientific explanations for it can depend on the field, the type of physicist you're talking to. So particle physics, string theory will think of zero-point energy as the amount of energy stored in like strings, essentially. Yeah, ZPM. Nice. I did it because I lived in Scotland. Z took me a long time to get out of, but yeah, it is definitely variable, and I appreciate the question. For this, I don't think it would necessarily relate to zero-point energy, although science fiction has treated that as such. This idea that you can have a single particle that stores a ton of energy in it. that's where people kind of lackadaisically throw out, oh, it's 0 point energy. You can also think of it being like a singularity, where that's kind of the general relativity, right? Where the amount of energy required to create a singularity, that can come from it too. And then string theory is a whole other thing. So, but this one though, this is more looking at the idea that however this molecule is structured, whatever bonds they have in this molecule, this magical molecule, when those bonds are broken, that releases an insane amount of energy. So this is like, nuclear fission type, that can happen. So there exists a molecule that has fictional capabilities, that is bonded in a fictional way, that when broken releases a ton of energy. And if you're able to create a chain of these molecules, then you would have theoretically enough energy stored in that to power an entire civilization. So we love the Omega molecule for this, and I think it's kind of exciting what the possibilities are. Now, Seven throws out the term that they needed boromite ore to synthesize more Omega molecules. Sure. We're so in the fiction realm of sci-fi at this point that, like, they can kind of use whatever they want. But we can think of it like there needs to be some boromite, possibly, has a similar bond that you can use to chain these particles together, I guess, is how I would kind of interpret that. When they did it, it tore up. Janeway was like, so how did that go when you synthesized it? Because they want to trap it. The Starfleet has the directive to destroy it. She's like, yeah, it was 29 vessels and 600,000 drones, so don't do that. Well, Janeway's here, so don't do that. Thank you. I'm particularly proud of that synth pop. I am very proud of that. That was one of those moments where you're like, oh, genius. So, thank you. So Janeway wants to get injected with this erythrosine. And the doctor's response is, oh my god, are you about to take a stroll through a supernova? So particularly what they have is Theta Radiation, which is made up Star Trek. No worries. Yeah, I like this too. I like the secrecy aspect of it. But, so erythrosine is used to protect from theta radiation. Now, theta radiation is a made-up Star Trek thing that is the byproduct, the radiation that you get off of warp cores. So I'm okay with this, right? Because warp cores are sustained matter-antimatter reactions that are releasing a lot of energy. Now, when matter and antimatter interact in our pre-Cochrane era, it releases, it just releases electromagnetic radiation. So light. You get a ton of light that comes off of it. And because we've talked about it being like positrons, there's no radiation expected. Try to contain yourself. Try to contain your amazement that they've made it up in Star Trek. But the matter-antimatter reactions in the warp core itself, we imagine would only result in electromagnetic radiation, photons. Theta radiation is made up. We don't know what it is, but I would imagine that it's probably a byproduct of some other component of the warp core that is not just the matter-antimatter. Possibly, we can go from the dilithium to the warp core matrix to all of these sort of things. There's a lot of components going on that are required to generate a warp field that that could cause this made-up radiation. But what we do have, what real pre-Cochrane radiation that we have, is alpha, beta, and gamma radiation. I always get these mixed up. I always get alpha and beta mixed up. One of them is stripped helium particles that are very dangerous and bad. Another one is electrons. those are the ones that I get mixed up. Those are alpha and beta, so I'm not going to say which is which because I will get it wrong. It's my Schrodinger's cat of radiation. When I collapse the curve, I always collapse it in the wrong way. And then gamma radiation is light. That's electromagnetic radiation at incredibly high frequencies. It could be trilithium residue. Sure, I love it. We'll just take the made-up stuff and just say that the trilithium from the dilithium results in theta radiation. We'll just go with that. I love it. But they thank you. Thank you, Synthpop. This is why we have brilliant people here on these streams to save me when I especially my proper nouns are completely awful all the time. Thalaron radiation, yes, is also banned. That's another Star Trek one. So yeah, alpha, beta, and gamma are our pre-Cochrane forms of radiation. Anything else is Star Trek. When do we get to quad lithium? Well, I'm a consultant now, so if we can come up with quad lithium and make it not sound dumb, I would love to work that in. So they have so this idea of the omega molecule, like I said, is pretty brilliant. I love when they're trying to figure out what is happening. Like, the rest of the crew is in pure speculation mode, right? Harry Kim especially. I mean, even Chakotay has to be like, dude, Harry, tone it down. Like, just do your job. Because she comes in. Well, yeah, first he's working with Tuvok on the warhead that she has to increase to 80 isotons. Sure. Then he gets reassigned to go help in the warp core with their shielding, and he's talking to Chakotay, and he's like, maybe we're detonating a protostar. Yeah, sure. Maybe we're detonating a protostar and opening up a wormhole to the Alpha Quadrant. You know, I was wondering this. That's really funny, Real House. I love that. This sci-fi drinking games are the best way to go. I love it. Every made-up science word. Which is, like, and then the best part is when there are words that sound made up and then they're not. Like, that's why tachyons always blow people's minds, because everyone is just like, oh, a tachyon is definitely made up. That's not a made-up thing. But I wonder how much classification levels Starfleet deals with, right? And I'm glad you brought this up, because it actually reminded me of, like, when I worked in the government stuff, I remember, like, my first super classified briefings, it was kind of like, oh, I'm here. I'm in the room now. And I feel like that was Harry Kim when she gets them all in her ready room and she's just like, all right, doesn't leave the room. I'm going to tell you what's going on. I could just imagine Harry Kim's excitement of being like, I'm in the room. I'm in the room. I get in on the secret. So, yeah, exactly. That, you know, it's nice. Harry needs some wins. So, yeah, when you get read in and then you get, like, all of your, you know, your briefings and everything, you're just like, oh, I'm on the other side. And I love it. So, she basically breaks down this, well, first one I want to talk about is this idea of blowing up. He's like, maybe we're going to blow up a Type 6 protostar. This is when he's just, like, speculating on what they're doing. That would detonate and open up a wormhole to the Alpha Quadrant. I do kind of like this idea. I mean, yeah, he's not getting promoted anytime soon. So a Type 6 protostar, Type 6 is made up. Protostars are not. Those are stars that are just about to undergo, like, they're just getting hot enough and dense enough that they're about to fuse hydrogen into helium. But they're still hot, dense clouds of gas that you wouldn't necessarily want to go near. And could be, I mean, there's still a lot of energy going on there. There's still a lot of gravity going on. So there is some instability to it. And you can imagine there being a pretty deep gravity well. Now, we don't know what Type 6 is, so maybe we could think about it being a super massive protostar, like a protostar that when it is born, it will be one of the very, very massive ones. way up there on the HR diagram that, you know, would result in a black hole when it dies and doesn't live for very long. So let's go with that. Let's say a type 6 protostar would be a very, very massive star that would have a high gravitational well and small radius, really, really bright. If you detonate something around that, you know, that's playing with space-time. And when you play with space-time, we could form wormholes. I'm not opposed to that as a theory from Harry Kim, or proposed just in the writing. I think that's kind of brilliant, and I think that that would be awesome. Yeah, exactly. Like, it just needs a kickstart, and then if you kickstart it in such a way, all that energy is going to be released, and if you can control that energy release, you could build a wormhole. I'm not opposed to that. I think that that's kind of smart. I like that a lot. But that's just this is just what it is. I mean, Synth Pop, I completely agree, because this is so like those moments that Harry Kim gets the chance to say, maybe we're going home. You know, like, are we going to the Alpha Quadrant? And he just, oh, my heart breaks. Yeah, we love him. And yeah, Aaron, also Stargate. Exactly. But agreed, Andrew. When we play with space-time in Star Trek, it's usually a pretty bad idea. And it's not what Janeway's doing anyway. It's just Harry Kim being eternally positive and hopeful and just wanting to get home. But she then has her meeting. Harry's through the wall. He's on the other side, so he gets to be involved in this. Which, of course, we know in Voyager, it is not staying in that ready room. It's just going to stay in the ship. But, has the same energy as a warp core. So she said a single Omega molecule has the same amount of energy that happens in a warp core. Single molecule. If you are able to chain them together, you could, in theory, power a civilization forever. It was synthesized by a dude named Cataract in the human species. Oh, shoot. Okay, I'm going to rely on... Again, my proper nouns are getting me. If anyone remembered what the quadrant was, not the quadrant, the sector was that they can't travel through, that Cataract did this. Oh, I did write it down. Lentaro sector. I think it sounds like a lot of other names. I didn't find anything. Yeah. But it was the Lantaro sector, was where it was like this research station that he was trying to create this Omega molecule, and it went bad, and 120 some people died, and it caused so many ruptures in subspace that extended for light years that you can't create a warp bubble in the Lantaro sector. Now, okay, I'm okay with this. I think that this is smart, right? When we talk about warp drives and how they work, they talk about subspace displacement, right? It is. And subspace, remember, is that area above and below our trampoline. So, regulars, if you have a cocktail in front of you, you can drink, because we're talking about our trampoline. Drink. Yeah. So, that trampoline, if there's right, when you're trying to build a warp bubble, you're going to need to displace subspace because you're bending your trampoline into subspace somehow. I think you'd be like an instant type 1. You're like a type, whatever's the better civilization, like a type 0.1 or type 0 civilization, if that's the best. Because, right, we have Dyson spheres are like our highest achievement for a civilization to be able to power. This Omega molecule is like the next realm in that. So, but if it explodes, right, and we can think whatever sci-fi-ness is happening here that results in these molecules storing so much energy, subspace is a good place to go for this. Pun definitely intended. That it stores so much energy and there's so much displacement to subspace that you imagine when it releases this energy, when it explodes, when it destabilizes, you've shredded your trampoline. That's kind of how I'm visualizing it. Like, there are just holes and it's shredded. And so when you're trying to go to warp in an area that's completely shredded, you just can't. You can't. You can try to navigate the threads slowly, right? Like, you can get from one point to another. The threads are still touching each other, but it's pretty much shredded. So the warp speed limit from force of nature, that is slightly different. And thank you for asking about that one. I hadn't intended to talk about it. It's a really good comparison. So the force of nature one, that's where so many people have gone through warp that it has become an unstable region. That that's slightly different in the sense that, imagine that your trampoline has been warped so many times that it's like an old sweater, that it's now so stretched and thin that it's all just kind of like loose and gross and not able to sustain a warp bubble. This is where it's like actively destroyed the fabric, and so you can't form a warp bubble in it. So they're two separate ones. Type 3, where civilization harnesses. Okay, yeah, so there's type 1, type 2, type 3. I never remember these. So this would be, I guess, a type 3. I mean, if we're going with that definition, yeah, the sweater. If you take Wesley's sweater and you wear it a lot, it's going to stretch out. And that's kind of like the Force of Nature episode. We should add Force of Nature to our list of episodes to talk about, actually. That's a good idea. Good idea, me. And also Billy for bringing it up. So yeah, those are two sort of separate examples. And yes, this would be like maximum ability to harness power and harness energy. All right. So she compares all of this to Einstein and Carol Marcus coming up with the Genesis device. So one being pre-Cochrane, one being post-Cochrane, but great advances in technology that are then you don't want to touch because they're too dangerous. 7 has an idea here. I'm already at the half hour, so I'm going to try to wrap it up. But it's such a good episode. There's actually not as much to talk about in Cold Front, so I think we're going to be okay. But she wants to build this harmonic resonance chamber that captures the inverse frequency to dissolve the inner harmonic bonds. Has a of technobabble. But basically what they're saying is that you have this perfect particle, and they show it being like multiple bonds all in this, that it sort of looks like a fancy, basically looks like the toy that they're playing with at the beginning of the episode. The Vulcan stick puzzle, Calto. When you win Calto, it kind of looks like that. I called it Vulcan stick puzzle. It's Calto. Yeah, for sure. Ultimate Borg tech. Because they have assimilated all the technobabble. But yeah, so the molecule looks like this chain. And basically what the idea is that you're going to find, and this I think is actually a slight mistake in a fun way because we've dug into it. We're not going to be mean about it. It's just interesting. But what she wants to do is find the harmonic resonant frequencies that hold it together to sort of pretty much vibrate at the opposite of that to make it fall apart. Now, vibrating at the opposite of that isn't really possible. That's not really what we're thinking. But the resonant part is really smart. That is saying, like, if we hit it at the resonant frequency, it will start to do this, like walking on a bridge in time or finger on the wine glass. You start to get this resonant frequency, and then it falls apart without necessarily causing a cascade reaction. Yeah, like the Tacoma Narrows Bridge. And Parisi scores. Tell Paul we made that connection because I love that. So that's kind of what she's saying, right? We're going to create this resonant chamber to dissolve the bonds. We're going to find those harmonic bonds, the ones that share a resonant frequency, vibrate at that, and it's all going to disappear. I love that. All right. So, that's how they're going to destroy it, is the idea. They can't blow it up because bad things are going to happen. They can find this chamber. But then Seven kind of starts to get a little bit obsessed with it and figures she can use this to actually contain it and keep it from destabilizing. The mistake that they made is then when they isolate the Omega molecule to an M-class moon, a pre-warp civilization that has discovered this capability. They've built it. And when they go to talk to him, they said that they have managed to create 200... Sorry, I'm reading my notes. Patrons get my notes, by the way, so that's my little plug. My commander level patrons get my notes. What they did is that they built the containment field at 1.68 terahertz that were at the molecule's own resonance. And Seven's reaction is like, oh, that's brilliant. The mistake is that the way that it's described is pretty much exactly like the resonance chamber. That's the fact that they're using resonance with the molecules. The science that they're doing is the exact same thing. So, when Seven wanted to use this resonance chamber to store it, that's exactly what this. Now, credit where credit's due. It could be that she was commending them for being a pre-warp civilization who had this breakthrough and saying, oh, that's really smart of you guys. But the way it's presented, yeah, it's because they're talking about doing the exact same thing. They have to get it out of there. They're using duratanium shielding. So we have, in this chat, we've come up with quadrilithium, and then DTG had a whole bunch of other ones. Now we have duratanium. So, like, tritanium, now we have duratanium. Shielding. They're super violating the prime directive here. Yeah, tetralithium, that was it. And they have to get it out of there. It's strong hole. Mm-hmm. It's the equivalent of vibranium. Yeah, this is just a really strong one. Equivalence it's made up, which we love. Duranium, they do have... Yeah, duranium... I think starship hulls. They've talked about that before. I love it. It's just peak technobout. Yeah, this is super violating the prime directive in the best. We definitely do, Brad. I should start doing that, actually. Start figuring out as we've broken up all of these. I mean, that's what she says. They're like, isn't this going to be violating the prime directive? And they're like, as Bob said, super secret military operation. We're good. This supersedes that under all circumstances. I mean, I'm not opposed to that in the sense that they're essentially saying that if a civilization is capable of synthesizing an Omega molecule, that's almost equivalent to being smart enough to have warp drive. It's more just that we're getting ahead when the prime directive is established, because it's like, well, you're about to find out about us anyway, so we'll go talk to you. This is like, you are about to blow all of us up, so we're going to go talk to you. So I do not disagree with the prime directive violation here, and I do think that it should actually fall under the prime directive, such that they have synthesized the Omega molecule. Now we can go talk to them because we got to tell them to stop what they're doing. So I am on brand defending Janeway here, but I'm okay with it because, yeah, thank you. I'm glad. Yeah. All right. I think that was pretty much everything. Oh, they do. So the kind of cool thing just at the end. Yeah, exactly. At the end, they do manage to transport it safely. They build sort of, one of their transport pole containment fields. They do transport it into the resonance chamber. They do start essentially what their plan is that they're going to try to neutralize as much of it as possible, send it out, and then let it like self-implode in a contained environment that's possible. Thank you. Oh, Billy, I know you reached for your tech manual as soon as we asked about this. I love it. Yes, the transport enhancers. But really they're using the transport enhancers as a containment field, right? Because they're going to have to like open the door and they don't want bad things to happen. They do get it in the chamber. They do start breaking it down. And it's then as they're like applying this resonance to it, and then Seven notices like it's just starting to fall apart on its own. Like it's doing what we want it to do without me making it do that. And then she glimpses through the thing and sees this beautiful godlike moment right before they jettison it, which is kind of cool. I like to think that was more metaphorical, that it wasn't actually happening, because I can't science that. Other than, okay, I said that, and when I took my notes I said that, but now that I'm saying this here, maybe there's something special about that resonant frequency that causes it to stabilize. Maybe? Yeah. That's awesome. That's really funny. But yeah, I think that, I don't know. I suppose it could be, but we've never seen anything like that. I mean, so this is in the realm of like sitting on that line between science and fiction. It's not, I'm not going to rule it out as in like science says no, but science right now says probably not. I guess we'll classify it that way. All right, we need to move on. We got to get and talk about Cold Front, but I'm glad everyone here loves the Omega Directive episode as much as I do, because I think it's brilliant. All right. Excuse me. So the next one we're going to talk about is Enterprise's Cold Front. I love this episode. This is early on. This is like, it's first season of Enterprise, but we are now starting to get the big arcs in, thank you, big arcs in Enterprise. That is what it's known for. I really do like Enterprise. I need to do a rewatch of it. So forgive me if there are Enterprise friends and fans in here. I have not watched it in a long time. So please feel free to chime in. I do, after watching this, I was like, oh, I just finished, I'm watching TNG with my friend Samantha right now. I finished Deep Space Nine recently. I think I'm going to go watch Enterprise. All right. Anyway, I did remember Daniels. Daniels shows up, and at this point, he's still crewman Daniels. And they are, oh, Aaron, all right. It happened. He did it. He said it. You know, it is the biggest earworm. So for people who haven't watched Enterprise, is the biggest earworm ever. And I think that's why people don't like it. It's also very, for any of us who were sort of 90s teens, it just feels dated. It feels like I'm about to watch Armageddon. So, but I will give you credit, Aaron. That was solid. So, anyway, the thing that I love about this is that everyone's in a little bit of pain right now and will not get this out of their heads. So, you know which username to wake up cursing in the middle of the night when you can't get back to sleep. Archer is adorable in this episode. Archer is adorable in this episode. We have an Awarfable. We need an equivalent for Archer when he's just at his peak innocent Star Trek captain mode. Because they basically are like, hey, we've detected a stellar nursery with ships in it. He's like, all right, let's go say hello. Why not? He's so innocent. Archable. It's an Archable. I like that. All right. They go into this nebula. There's a transport vessel in there. So stellar nursery, this is essentially where stars are born. And they correctly utilize that by saying that there is when they find this transport vessel, they start talking to him. It's kind of cranky dude named Captain Fraddock, who's obviously at the end of his chain, but he's making money doing this transport. Actually doesn't care what he's doing. But he's bringing people on this pilgrimage to the nebula, where every 11 years this protostar blasts neutrons out in a plume. All right. This is kind of a combination of a few different stellar phenomenon things. One of which I didn't write down. But I know there are some astronomy people here, so you might be able to help me out. But protostars, pre-stars, haven't ignited, haven't started fusing hydrogen into helium yet. Plumes of energy, neutrons or otherwise, typically come from high energy events that are happening. So in terms of that, and we talked about that type 6 protostar earlier in the stream, I'm not opposed to this. The cyclical nature of it makes me think of the thing that I can't remember. The variable bursts that we get from white dwarf stars when they are pulling layers off of their companion stars and then burst on a regular cycle. That's the science behind it. I can't remember the name of it. But there are other things. So not gamma ray bursts. Gamma ray bursts are, well, the different flavors of gamma ray bursts. You could argue is this, but they're from usually dead or dying stars. So that's where I think we're starting to like mash things up here. It's not quite the black hole orbiting the other black hole. Andrews mentions quasars. Yeah, I mean, quasars are active galactic nuclei. All of those are on a galactic scale. The gamma ray bursts and the white dwarf variable things that I can't remember are with dead stars. So this is like a protostar variable. So all of that being said, and thank you all for chiming in there because those are all great ideas. Space is weird. We haven't detected everything. I'm not about to write it off just because we haven't seen it. So a variably pulsating protostar, I'm okay with. And every 11 years, I'm also okay with because we're talking about stellar life cycles. So the amount of time it takes to start a form and start fusing hydrogen into helium is very long compared to 11 years. So you could have this cyclical nature. So I'm just saying I'm good with it. We don't have an example of that in astrophysics. I don't think there are any. I don't know of any models. I didn't study protostars. I don't know of any models that would predict something like this, but I wouldn't at all write it off. No worries, Andrew. But thank you, and thank you, Billy, for trying. But we're okay with that. So they're in a stellar nursery. They're observing a phenomenon. There is a protostar, a star that is about to become a star, at which point it will blow off, it'll kind of blow away a lot of the clouds around it. But stellar nurseries are light years and light years across, so it's okay. Every 11 years, they're doing this. They dock, which is awesome. This is, again, I was remembering, I really like Enterprise. Then they shake hands. And I'm using Star Trek to escape from a lot of life right now, and these streams are for a lot of us to mentally health recharge. And so all I can do is apologize because I know it pulled a lot of people out when he's just like, shake my hand. Shake my hand. It's customary on Earth. This is what we do. And I was like, yeah, it used to be. Anyway, it is what it is. We don't have to dwell on it because we're here to not think about those things right now. They give presents, and Trip is adorably dorky about it. They do start showing them around the warp reactor, and he's like, this is where the gravimetric field displacement manifold takes place, otherwise known as the warp reactor. I like that. Talks about it running on antimatter. Check. Then he finds out that the people he's giving a talk to are, like, one of them is a warp field expert, so I've been there. I have been there. Particularly when I worked at museums. When I worked at museums, talking, going through my spiel. You see someone, looking at an exhibit about a black hole or, all the many things that we have. It's always like, oh, hey, like, here's something cool. Let me share a cool fact with you. Let me show you this exhibit. And then someone's like, yeah, I'm a retired aerospace engineer and I did this stuff for 30 years. And then it's like, oh, okay, never mind. I went into my spiel too soon. So my advice out there, if anyone is into science communication or trying to get better at it, those were all lessons that I learned to learn your audience before you break into your spiels, because it's more awkward for them to have to say, I know what you're talking about. But anyway, we live and learn and we move on. But the way he's talking about it, matter, antimatter, energy happens. That energy is channeled through the conduits to the nacelles, where they contain warp coils that create the subspace displacement field. We just talked about the subspace displacement field. So all of that's good. They ask the question, how do you regulate the positron flow through the dilithium matrix? Positrons are antimatter. They are the antimatter equivalent of electrons. So there are positrons here. That's at least one of their antimatter components that they're using. It flows through the dilithium matrix. How do you regulate it? Dilithium matrix is kind of like, I like to think about it as partially like control rods for nuclear, processes. In nuclear power plants, you have material that is there to regulate the process, I guess, to keep it from cascading out of control. I also think of dilithium kind of like a catalyst. Like, it's there to help keep the process going and also keep it under control. So, regulating the positron flow through the dilithium matrix, all right, I'm okay with. There's a matrix of dilithium. It's there to control the process, and you want to regulate the flow of positrons through it. I'm all right. And then he talks about it being magnetic constrictors. I'm also okay with that. There's electromagnetism, positrons, as antimatters of electrons or charged particles. So you can use a magnetic field to adjust their direction and their motion. So for all the technobabble crap that we've laughed about, and we continue to laugh about, and we love, and we hold it close to our heart, sometimes they nail it out of the park. And this is certainly one of those times I love. They do go through a plasma storm, start to lose matter. All of this is awesome technical things that are happening. And there's a whole other story to this. Essentially what happens is, as they're giving the tour, one of the people slips off, sticks his hand up, and pulls out this junction. They go through a plasma storm, which would make sense for being near a protostar in a stellar nursery. Plasma being superheated gas. So as you have this protostar, that's superheated gas. It's probably plasma. And then there's a storm of it. Sure. Maybe there was an ejection from the protostar. Remember, it's about to plume every 11 years, so that could be a precursor to it. Anyway, all fun stuff to talk about. They start to lose power in the ship. Essentially what's happening is they're having an antimatter cascade. So the dilithium is not able to control the process. The antimatter is starting to get out of control. However, the dilithium keeps the matter-antimatter reactions is no longer working, and you're getting a cascade of antimatter. So you're getting a big buildup. If it makes it to the warp core, it's like having a, like Chernobyl type thing is about to happen, because these reactions are now going to be a cascading process. But the dude that stuck his hand up and pulled the thing out, that was stopping the flow of the antimatter to get to the engine, but he did it before the accident happened. So how did he know that? And essentially, this dude is actually a Suliban soldier in disguise. This is where Daniels pops up now, and he pulls Archer aside, and he's like, you and I gotta have a conversation. And Archer is rightly, it's well written, how he's just like, crewman, ensign, stop talking. I got things to do. And then he's finally like, okay, I'll listen to you in my ready room. And he's like, no, I want you to come to my quarters. And he's like, crewman, I'm in charge. You're not dictating where we go. And then he keeps saying enough that Archer's like, fine, I'll come and I'll listen to you because this is weird that you know this stuff. It's really well written and it's really well acted. Yeah, you'll see when we get there. That's not helpful. Like, that's not, you are multiple ranks below me. And no. He prepares his food too, which is weird knowing that we have replicators, not weird for, commanders of starships. But that's fine. He's his, junior grade personal assistant. That's a thing. So that's no big deal. But the junior grade personal assistant is not going to say, hey, come to my quarters in the middle of this crisis because I need to tell you something. No, that's not what happens. But he does convince him to go. He says that he's actually a time traveler. That there is that when Archer was taken before, the temporal Cold War was mentioned by the Suliban. And he shows him his temporal observatory, which I love. I love it. He, opens it up and you see all of these timelines that are happening. And now there's no rhyme or reason to it for us. We have no idea what's going on. But he seems to be like, yeah, that event and then that event and then that event. But the cool thing is you're seeing these streams of time, which for all the time travel episodes that we've discussed in this series, that's usually how we end up describing things, is trying to think of streams of time that are changing. And yeah. And here you will see a black hole near Romulan, which then the line disappears. That's really funny. Yeah, creates its own universe. It's fine. And the cool thing is he does kind of talk about this, history of time travel and what happens when people get this technology and what rules that they say to deal with it. And it does look wibbly wobbly, timey wimey. The Silic, the Suliban, only have enough technology to partially materialize, but he's from further in the future where they have the capability to travel, and one of the rules is that they can only time travel to do research. But not everyone follows those rules. Try to contain your amazement. Yeah, exactly. And his is a bird of prey going around a sun. What's that? Research. But Silic saved the ship, but Daniels was sent to, capture him, and then... So there's, there's holes in this story. He's like, well, why? But if he saved... What's happening? And T'Pol... I gotta say, I don't usually agree with T'Pol because she's pretty Vulcan-y, and my abundant enthusiasm would struggle in a Vulcan-verse. I guess we can put it that way. But she's asking the right questions. She's like, this is too convenient. Your junior grade personal officer is telling you he's a time traveler. Check that. That's bonkers. That's so funny. Would you? No. I think most of us wouldn't. And, it's like, I love me some Spock, but I think the Spock that I love is partially that half-human component. Sarek is close to my heart, but then Sarek did the nasty with the human. So, there are Vulcans that I would get along with, but I think wholesale, I would struggle on Vulcan. I guess we'll put it that way. It is funny because he basically tells Trip and T'Pol, all right, I'm going to fill you guys in on this because there's a time traveler that's going around. Yeah, exactly. And yeah, we can't, okay, for me trashing Vulcan, I do have Idic, tattooed on my wrist. Something out. And Vulcan script on my arm, so I've lost all credibility in my venting about Vulcan. But I still think I would struggle there. I love them, but I would struggle. And T'Pol pushes my buttons a few times. But I agree with her. T'Pol and Trip are told, hey, thank you. There's a time traveler here. You're gonna have to help me figure this out. Trip is the worst at keeping secrets, man. He's actively hounding Daniels as they're walking through the engine room with other people around going like, wait, so does that mean you're not from Illinois? And you told me all this other stuff about you that I now find out isn't true. And I'm like, dude, shut your mouth. It's not everyone is supposed to know that there's a time traveler here, and it's people like you that are the reason that time travelers need rules. So, it does. He was not being quiet about it at all. Yeah, and well, I think she wasn't necessarily, she was kind of dismissing time travel, but I think T'Pol was more dismissing the idea of the temporal Cold War. That, you know, he's like, hey, I've heard of the temporal Cold War from 2 places now in that exact phrasing. And she's like, no record of that from the Vulcan Science Community. Yeah. We just talked about this trip. We just gave you the security clearance. That's really funny. Yeah, he is not one to emulate for security clearances. On the other hand, we never heard about the Omega Directive again, so good on the Voyager crew. I love it. But yeah, one of the things that I love is when Silik, the Suliban, basically confronts Archer. He's just like, who's looking for me? I know there's someone here. I know someone's looking for me. You're on the wrong side. Don't listen to him. And I know that there's a time traveler here. And he's like, I don't know what you're talking about. And then Silik is like, and this is the best part that we're going to end this on. He's like, I detect tachyons. You have nothing on this ship that would emit tachyons. Okay. Tachyons, we don't have to go into the whole thing. If you want to learn more about tachyons, I do have an entire YouTube clip describing the science of tachyons, and we have 1 minute left because we got too excited about the Omega Directive. But tachyons would be a byproduct of time travel because they are real particles, pre-Cochrane, science particles that go faster than the speed of light. We have never detected them. They are completely theoretical. But because they constantly go faster than the speed of light, they break all understanding of causality. Cause and effect, because our understanding of cause and effect is predicated on information traveling at or under the speed of light. Therefore, when people time travel, they are breaking causality like nobody's business and could have a byproduct of tachyons. So tachyons being tied with time travel, I am there for. I am totally in favor of that. The last sort of thing I will mention is, and that is how Daniels was busted, because he had there was an abundance of tachyons on the ship. Archer gets into a fight with Silik, opens up the bay to the vacuum of space. I mean, it's kind of, and chronotons and metrions, there's multiple made up particles that we've used. So chronotons are made up Star Trek. Chronotons are time particles. They're like the fundamental particles of time. Tachyons are a byproduct of time travel. Different particles, if that makes sense. All made up. Well, tachyons are not detected, but tachyons are a byproduct of time travel. Chronotons are time particles themselves that one could harness to travel through time. If that works, I think that makes sense. Anyway, I'm over time now, but when Archer's exposed to the vacuum of space, I'm like, that's not what being exposed to the vacuum of space would look like. But then once he gets into the bridge, he is like gasping for air and he's all red in the face. And so I was like, well, they tried. They had the budget that they had to make it accurately look like he was exposed to the vacuum of space. The errors are, I would want him to keep his eyes closed. I would want way more air brushing past him for that small of a space. If the air has all gone, then his skin and eyes should be not doing great, and he would be pretty frozen as well. But budgets, we'll let it go. Oh, no, that's okay. Cataclysmic variable. I think it was a class cataclysmic variable. I will I will include this as a question for my Astronomy 101. That's a great username, but thank you for following me. And I will address that on Friday during our astronomy class. I will look that up. I am not doing an interview tomorrow. That was like a one-off thing, but it's not but it's something I would do again. So if there are people you would like to see me interview, I really enjoyed it, and I really enjoyed having people there. I did. I asked my own question. And we will address it. I gotta write that down. This is why I carry notebooks everywhere I go, because of this. Variable white dwarfs. Okay. The other thing, so Domestic, thank you for asking. I'm hoping to do interviews in the future. If there are people you would like me to interview, I don't have a set schedule for them, but we will start doing them. They didn't. The Earth is round. The Greeks knew the Earth was round a long time ago. The Earth is round. And yeah, we've seen it many times. And we've seen other planets many times. But anyway, I do recommend the documentary Beyond the Curve. That was actually, I thought I would not enjoy it, and it was very interesting and a very good analysis of the flat Earth people. But yes, if you have people you'd like me to interview, let me know. Or ideas for that. I'm always welcome to ideas. Please check out my Patreon. Links are down below. The other thing I'm going to start doing is I am still going to keep putting these recordings up on YouTube because I know people like to watch the whole conversation. But I am also going to start putting up 10 to 15 minute snippets of the science that we get from these. So, science of the Omega Directive. And we'll just pull out the fun stuff that we talk about. I will make a video and separately recorded, and I will put it on YouTube in shorter increments so people can watch that. And I love our tangents, but sometimes people just want to watch the science. So I get it. But anyway, I'll make that early release a benefit to patrons as well. So anyway, thank you all again for hanging out with me. This was a blast. I may stream Mass Effect later this week as well, but I will be back on Friday for Astronomy 101. And until then, live long and prosper. It's been a pleasure. All right. Thanks, everyone. Bye.